Hello, thank you for inviting me. We live in the age of discovery, the discovery of linguistic data on a very large scale. And today I am going to talk about the map of the web in terms of the genres. And I will start first by talking about the theory of what genres are. And one of the things is that you can think of genres quite naturally as the opposition of form and function. We have direct access to forms. We can count, for example, the number of nominalizations of verbs in the past tense in any given text. But what we're interested in is the function, why this text is used. And this is definitely a much more interesting question, and we can approach this, and the way this is typically approached via a typology, via a set of genre categories. And I would like to show that there are some problems inherent in this approach, and instead I would like to propose a description of genres in terms of a topology of functions, how similar texts are in terms of their functions, and I will show that this is a more reliable approach. Once we know how to describe genres, to apply this to the web, we need an automatic classifier. And modern neural networks, they provide fairly reliable estimation of what is needed for genre classification. But neural networks, they don't give, they operate essentially as a black box. You have a map, but you don't know why you have certain features in this map, and therefore you need to have some kind of linguistic analysis of the predictions made by the neural networks. So let's start with the typology of genre labels. Many people approach genre analysis by focusing on a particular genre, for example, the genre of research articles or newspaper genres. But if you look at the kinds of texts we deal with even in our daily lives, then we can see a much greater variety. So then even within the newspaper genres, we can definitely distinguish between the straightforward reporting and opinion pieces and feature articles of various kinds. We can probably say that there is also a difference in the audience, which impacts how texts are presented stylistically. Probably articles in the Sun, they're different from articles in the Guardian or in weekly magazines. Again, here the form, how something is published, is likely to have some impact on the stylistic features. But again, going beyond this, we will have many other kinds of texts, and we can have reports produced in our projects, and they are very different from reports as appearing in the newspapers, even though they have exactly the same name, right? So, and if you try to capture this variety of text types we deal with in daily lives, so what we want to capture how the web is shaped, the totality of texts on the web, then our typology is likely to be quite long. Even before the arrival of the web, there was a very nice PhD by Kirsten Adamczyk, and she worked with the list of about 6,000 genre labels, and this list is definitely quite comprehensive. But first of all, this was compiled before the age of the web. In the first instance, there are no Wikipedia articles, for example, or personal blog entries in this list. But what is more, genres, they mutate very much like viruses, and we in each individual text we are quite likely to have a range of sources from we can see that quite often texts are produced from with a range of stylistic features, right? This is a typical example of what we can call citizen journalism. In a sense, you can say that in its function it is somehow similar to how news is presented in newspapers, but at the same time this is not entirely news and this is not entirely an editorial. Obviously, this is just a private reflection of what someone sees around him. This is taken from a Facebook post. So instead instead of dealing with the labels and then all the problems we have with hybridization of those labels, we can think of several generic functions, right? So for example, the text which so this kind of text, right? To some extent, it provides an informative report of recent events, and this and you can judge to what extent this text provides an informative report of recent events. And in order to make this judgment easier to process, you can have the prototype, right? And the prototype genre which provides an informative report of recent events is newswires. Then many texts, so that if you look at newspapers, you will also have texts which try to persuade the reader, right? And then probably there is some function of this kind in the text I showed, but the prototypical genres in this case are either opinion columns or editorials, as you can see in the newspapers, or nowadays these might be argumentative blogs. Yet another example of a function is to what extent does the text evaluate a specific entity. Uh, the prototypes for this are reviews of something like products or locations or performances. And it's interesting that A, B, and C here, the codes, they correspond to the genre labels from the Brown corpus. So to what extent the texts we have on the web are similar to the texts we have in the Brown corpus, which was compiled on the basis of texts published 60 years ago, it's a question. But in terms of the functions, I think that you can find some of the functions which were collected for the the functions of the text collected for the Brown corpus are likely to remain the same. And finally, this is an example of a text which was uncommon at the time the Brown corpus was collected. These are texts reporting a personal story about someone's private life. And nowadays, again, we have a number of texts of this kind. These are essentially diary-like blog entries. So in order to provide this assessment, we need a scale, and a useful scale in this case is a scale from, a 4-point scale from known. This function is unlikely to be there, or to put it in another way, the text is not like one of the prototypes listed in italics, or this is very much like the prototype listed in italics in terms of its function, right? So 0 is known, and this scale is designed to ignore hesitations, right? So it doesn't have the middle point. You can say that a function is present in a text, or it is probably present there, but only partly, right? And this helps in distinguishing texts from which are very obviously of this kind. Okay, this is the full list of dimensions. What I claim is that if you take any web text, it is quite likely that it scores on one of those dimensions, and we can take care of hybridization by essentially having a proportion of how much some of the functions they appear in any given text, right? So we have argumentative text, we have fiction, we have tutorials, we have newswires, we have le legal texts and regulations of various kinds, we have personal reporting, we have promotion, we have academic research papers, we have texts aimed at information, such as encyclopedic articles, we have reviews of various kinds, and I also have two categories which I think are quite important. The two functions which are quite important, they are present in a number of web texts, but in terms of data collection, I don't have sufficient examples. So what I need to train a machine learning model to apply it to the rest of the web. And the number of texts I have is quite small, and this applies to various examples of propaganda and appellative texts. I'm not very comfortable in classifying small ads or requests or call for papers to be classified as commercial promotion, for example. But at the same time, if we don't have sufficient number of training texts with this function, we can't proceed. Right? Okay, so these are the functions, and we want to classify the web using those functions. For this, we need a classifier. And what appeared in the past 5-10 years, a range of approaches which are based on neural networks. And what is good about neural networks is that they are based on a representation which is called an embedding. In embeddings, we have a vector, and the vectors are similar if the underlying words are similar in their meanings. The other thing is that recurrent neural networks, they cater for sequences. In the past, we used individual words, and now by dealing with embeddings, we deal with more general meanings. And again, in the past, we dealt with bags of words. We had only individual counts of features, and but tokenization had to be provided in advance. With recurrent neural networks, you can use sequences, and this definitely helps, so that that chunks of texts they can influence each other. And finally, a text usually provides a number of clues, and there is a mechanism which is called attention, which chooses what is relevant for classifying a particular text with respect to a particular function. So, for example, if we have a review, then in the case of a review, what is important is that there are certain aspects, for example, for which are useful for judging that this is a review. Pork belly is delicious, right? And then something these were amazing. Again, we're not interested in what is amazing. We're not resolving here the anaphoric references, but at least this gives us okay, a fairly good prediction that these bits are important for classifying a text of this kind as a review. Right? And now with a classifier of this kind, we can apply it to the web, and this is a kind of the map which we can which we can with which we can assess how often certain functions occur on the web. So all these corpora are billion-word corpora collected by crawling the web. UKWAC is a collection of texts from the .uk internet domain, and other corpora, Arania English and EN1010, they are crawls of English texts. Arania RU is a crawl of the Russian web, and because I have texts annotated for their function in English and Russian, now I can also show what are the similarities and differences in the map of the genres across different languages. What you can see is that the bulk of the web consists of argumentative texts, and if you want to have examples of argumentative texts, say from Arania EN, then you have 1.5 million texts, right, at your disposal to study at a corpus which is sufficiently large. for a number of investigations. And then you have reporting news. Promotion is definitely one of the most commonly used functions on the web, and one of the reasons for this is obviously this is not only spam, and probably the minority of texts in those corpora are classified as spam. These are just web shops of various kinds, and pages aimed at commercial promotion of goods or services of certain kind. And then finally, another function which is quite common on the web is providing reference information. Wikipedia is the prime example, but there are many texts of this kind. Okay, so this is all good, and what so but at the same time it is difficult, it is a kind of difficult to conceptualize what is the set of options available on the web. So you can represent this as a map. So now with neural networks, we know which texts are similar to other texts in terms of the embedding vectors, and but then usually this is represented in 300 dimensions. So what you can do, you can collapse this into two dimensions using a technique called TSNE, the dimensionality reduction technique, right? And now, okay, this is the map of the web, but there is so then I'm cheating here slightly, because this is not exactly the map of the web as we see it. This is the map of the Brown corpus and the BNC, the British National Corpus. And the reason for this is that I can show you the map of the web, but then in this case it will not have any categories there, right? Because texts on the web, they don't have annotation per se. So what we have is annotation of text in the BNC and in the Brown corpus, and you can see that the classifiers are reasonably reliable, so that this area corresponds to fiction in both the Brown corpus, so the categories K to R in the Brown corpus, and also the category for fiction here in the BNC. In a very similar way, in a different corner of the world of genres, we can see newspaper reports. So these are the newspaper reports from the BNC, and the A category corresponds to the newspaper reports in the Brown corpus. And finally, uh, in the bottom right corner, we see academic texts. J is the category of academic texts in the Brown corpus, and also a range of different academic texts in the BNC. And somewhere between fiction and newspaper reporting, we have various kinds of argumentative texts, right? So these are the three most common categories of what we can find. So in this case, in large representative corpora, and this roughly corresponds to what you can find in traditional corpora as well, right? So this is all good. This is fairly convincing, and if we have a large corpus, we can estimate its composition in terms of the basic functions. The problem is that this is all based on machine learning predictions, and it doesn't give reasons why certain functions are detected, right? So we don't know this. Neural networks, they are very efficient, but at the same time they operate as a black box. So one of the ways of interpreting this is by using lexicogrammatical categories, first introduced by Douglas Biber in his work towards the end of the 1980s. So we can, in principle, use some of the categories of functional linguistics, but the problem in in my research is that you can't actually use them because you need to apply them to millions of texts on the web, and detection of more complex lexicogrammatical categories is a bit challenging. So in terms of the here with the Biber categories, I detect something which is relatively simple. We have some lexical categories such as public verbs or time adverbials. We have part of speech tags such as past tense verbs, prepositions, or nominalizations, are a combination of a fact that something is a noun and it has a particular ending, right? We have some syntactic functions, those which are easy to detect by simple patterns on part of speech. And also we have some text level categories here, so such as type token ratio, right? And now we have those categories and we have predictions made by the neural network. So what we can do, we can train a logistic regression model and on those we with linguistic features as the independent variables. And the advantage of logistic regression is that it is essentially a linear model. There are much more successful classification models, and neural networks is one of the examples of successful classification models, which produce better accuracy in classification. But because they're non-linear, you don't know how features contributed to making a prediction, right? In the case of the logistic regression, we have weights for individual features, and this gives us a way of interpreting. So what is the correlation? It's not exactly why neural networks made predictions of this kind, but if we apply logistic regression, then logistic regression will make predictions on the basis of interpretable linguistic features. And by looking at the correlation of what is predicted by which tool, we can see what are the possible reasons, at least what is the prevalence of features predicted in texts with a particular function, right, by the neural network. So these are some of the examples. So if we look at, probably I can spend now another hour talking about what corresponds to what in this map. To make things short, because I am also running out of time here. So we can match functions. For example, argumentative text, right? So what we can have there, it is quite likely that we have larger number in comparison to other kinds of texts. WH questions, conjuncts, again, because this is argumentation. We also have a large number of propositions, which indicates greater complexity in argumentation. We have suasive verbs, and obviously this is mostly more personal argumentation, I think that. And this is all reflected in the features. Similarly, in the case of news, this is reporting about some events which happened in the past at a particular point in time. So we have past verbs and time adverbials. We also have prediction models. So this essentially means that what is likely to happen. Newspapers and various reporting texts not only report about what happened in the past, but also quite naturally they integrate predictions. And we also have the higher type token ratio. And this contrasts them with arguments, because in arguments, according to the statistics, we have larger number of cliches in the case, and this is also interesting that we have exactly the same pattern in legal texts. Legal texts, they are considered to be fairly formal, and usually higher type token ratio applies to more formal texts, but not in the case of legal texts. Um, What else? In the case of personal reporting, obviously this so one the strongest feature is the use of first person pronouns and also verbs in the past tense. They are less formal, so one of the indicators of the formality is the word length. It is shorter in the case of personal reporting. Again, another interesting thing is commercial promotion. It is characterized by a higher type token ratio and higher word length features. So then essentially this means that so they are more promotional texts, they are closer to formally written texts, right? And what else? Even though the number of prepositions, so this corresponds to how packed how informationally dense discourse is. It is lower in promotional texts. And now we can also look at how academic texts are represented in terms of these features. Longer words, a higher type token ratio, more conjuncts again to help with argumentation, a larger number of prepositions and larger number of nominalizations of various kinds. Right? Okay. So this is the end. I so the main take-home message is that if you look at typology, usually develops into a very long list of unstructured labels, and it is and because of the long list and because also of the potential of hybridization, it is difficult to deal with this list, and therefore taking a topological view in the sense of how similar words are, this helps, and you can make a reliable judgment by comparing each individual text with a small number of prototypes, or how similar it is to a prototype, to judge how useful this text is for classification. From the viewpoint of machine learning, you can use neural networks. The problem with the neural networks is that it doesn't provide interpretable features. And if you have both interpretable features and neural networks, then you can compare how the functions which are external to the internal features of the text are expressed in terms of the internal features of those texts, right? And it's also interesting that this comparison can be done across the languages, right? So, for example, if you have a particular function and it is expressed in, definitely a function is fairly common, such as academic reporting or personal reporting. So the function is fairly common across languages, but then in some languages, such as Chinese, the function of nominalization is it just doesn't work in the same way as it is in say in the European languages, and therefore you can say that you have predictions, and in the case for a particular function such as academic texts, and now you can compare this against how this function, the same function, is expressed in a language in which the particular lexicogrammatical feature doesn't work that well. The resources are available, so the classifier and the Bible-like annotation tools, they are available in open source, and annotations for a large number of genres, they are available as well. Thank you very much.